Hello, welcome again to Electronics Classroom, and today we will simulate how to set up a NOT gate, or we call it inverter, by using a BJT transistor. So first things to do, just open your Multisim software and create a new project and save it with your preferred name. For example, mine, I'll save it with a NOT gate as the names of the project. And after save it, we will have to load the electronics parts that we'll need to create a NOT gate, and for this case we'll need to have a BJT transistor. So go to database and go to transistors and pick a BJT transistor, and make sure you are using an NPN transistor, NPN transistor. And how will you know that this is NPN? Just look for the symbol. NPN is always pointing to the emitter. So this is one of the NPN transistor. Also, we'll need to have two transistors. So go to basic transistor and just take 10 kilos ohms transistors. We'll need two transistors. Also, we'll need to have a source of electricity, and we will use a DC source, two DC sources actually. First one will act as a VCC, and the other one will act as the input source. And also we'll need to have 3 grounds to connect the source, those two sources, and to ground the transistor. Also we'll need one switch. So go back to basic and pick one switch with just one key. And we'll need to use one indicator to indicate the signal. So I'll just use a probe. It's a red color, so it's going to be easily seen. So basically, the NOT gate acts as an inverter. It's switch the input signals. If the input signal is low, then that signal will be high. Same way as if the input signal is high, then the output signal will be low. So we will connect this so as it can act that way, and I will use two multimeters to demonstrate how the volts switch from low to high. So now, because our transistor is a main part of this NOT gate, will be at the center, and I'll connect the emitter with one of the ground. Also, we'll connect the base with one of the transistor of the resistor, and our switching will act as an inputting signals to allow to switch from high to low, and one of the source will act as a source input. So connect the source volt to the base through the switch, and make sure that the positive sides of the source is the one which is going straight to the base, and the negative part of the switch will go to ground. So for the part of collector, connect the collectors with one of the with the remaining with the remaining resistor, and the resistor with the VCC volt, and make sure the positive part of the VCC is the one goes to collector, and the negative part we will connect it with the ground. Now the output of this gate is between the collector resistance and the collector terminal. So our probe will connect it to the between collector, the resistance, and the collector terminals of the transistor. So the startup is complete, and we will test our scenario by running the simulations. And as you see now, the input is low. There's no volt across the base, which is coming from the source input, and the probe is on. So if I turn on, or if I just allowing the volts to flow to the base, the probes will go off just because it will act as a low volt. So when you have a low input or zero input, we'll have a maximum output. Let us connect the multimeter to see the actual voltage across the load and across the output signal. So connect the first multimeter. And the secondary multimeter across the transistor. So the first terminal, the negative terminal will be in emitter, and the positive terminal will be just above the probe in a collector. So, and make sure you just you have opened the multimeter and run again the simulations. So when we have a high input, that means we have 1 in input, we will have 0 in output. This is almost 0, and all the volt will go to the transistor, to the resistor, just because we've just opened the gate here by using this volt. So all the volt will go through the transistor, and there will be no volting in the output. So the output will be ground, and will have a 0 output. So when we have a low input, there is no voltage across the transistor. So all the volts will go through the probe, which is our output, and we'll have a maximum output, which is 12 volts. So this is how you can build your inverter, which will invert the input signal. If it's low, we'll have high output, and if it's high input, we'll have a low output. So this is what we call a NOT gate. Next time we'll have to simulate an AND gate and OR gate.